Integrating Claude into a professional development stack requires moving beyond the basic request-response patterns of a standard chat interface and into a predictable, structured environment. To build that structure, we are going to implement 3 core technical optimizations: real-time streaming, strict system-level constraints, and tool calling for deterministic JSON extraction. Before writing the implementation, ensure your environment is ready with Python 3.7.1 or higher, terminal access, and an active Anthropic API key stored as an environment variable. These SDK foundations are the prerequisites for building applications that function reliably at scale, moving your code from a conversational experiment to a stable software architecture. We begin with a baseline script to establish connectivity. First, install the Anthropic Python package through your terminal and initialize the client library within your script. Inside the message creation block, you must specify 2 primary parameters: the model version, in this case Claude 3.5 Sonnet, and the max tokens limit to control the length of the response. We reference the Anthropic API key from our environment variables rather than hard-coding it. This ensures your credentials remain secure and separate from the application logic. Running this baseline script reveals the standard synchronous delay. The terminal remains blank for several seconds, while the server processes the entire generation before returning the full block of text. While functional, this waiting period creates a latency bottleneck that often leads to a poor user experience in interactive applications. Our first optimization addresses this latency by replacing the standard creation method with client.messages.stream. This requires a structural update to the script. We implement a context manager to iterate over the streaming object, allowing the terminal to print individual text chunks as they are generated in real time. The difference is immediate. On the left, the user waits for a complete processing cycle. On the right, the interface responds the moment the first token is produced. By utilizing streaming, you align the application's feedback loop with the model's generation speed, creating an interface that feels responsive and active. Speed must be paired with control. We use the system parameter to define the model's persona and operational boundaries before the conversation begins. Structurally, the system parameter sits at the top of the API payload, isolated from the user messages. This separation allows the model to prioritize these instructions as foundational rules for the entire session. This is the primary method for maintaining model alignment. By defining rules in the system prompt, you ensure the AI adheres to your specific application requirements, even across long or complex conversations. To integrate Claude into a larger software system, we must move beyond text generation and into data extraction. Tool calling serves as the bridge that converts natural language into structured, machine-readable data. This process starts by defining a tools array. Inside, we write a strict JSON schema that outlines the specific properties, data types, and required fields the model must extract from the user's input. We then pass this schema into the API request. When Claude receives the user's prompt, it now has a specific blueprint for the data format it needs to generate. In many cases, the model may choose to respond with conversational prose instead of using the tool. To prevent this in production, we implement the tool choice parameter. By setting tool choice to a specific tool name, we force the model to execute the data extraction schema, bypassing the conversation entirely. Once the response is received, we access the input object within the content array. This allows us to parse the result directly into a native Python dictionary. Running the script now shows the result. A rambling user input is instantly transformed into a cleanly organized JSON object, ready for an API or database. With tool use implemented, your application can now treat the model's output as a predictable, typed input for downstream functions. The final script is under 40 lines of code. It successfully handles real-time streaming, maintains strict system-level rules, and ensures every output follows a validated JSON structure. Mastering these core SDK features provides the technical foundation needed to build more complex workflows, such as multi-step data pipelines and automated task routing. To further explore these implementation patterns, visit the Anthropic Academy at anthropic.skilljar.com and enroll in the Building with the Claude API course. Moving beyond the chat interface and into the programmatic depth of the Claude SDK is how you build AI-powered software that is both reliable and scalable.